All right, in this review problem, we're going to solve this second order linear non-homogeneous differential equation. We have y double prime plus 4y equals 3 sine 2t with these two given initial conditions. First step is that we're going to solve the associated homogeneous equation, y double prime plus 4y equals 0. And if we solve the characteristic equation, we get r squared plus 4 equals 0, which has the two roots r is equal to plus or minus 2i. And so that means that a solution of the homogeneous equation would be c1 cosine 2t plus c2 sine 2t. Okay, so that's our first step. Our second step is we're going to try to find the solution of or find a particular solution. Now, there's two ways of doing this. First, I'm going to do this by the method of undetermined coefficients. Later on, I'll do variation of parameters. Okay, so we get started. Now, we let y of t be equal to a times cosine 2t plus b sine 2t. However, we have to put a modification on this. And notice that 2i, so we have 3/2, the form of the right-hand side stipulates that it should look like this. However, this looks exactly like this, so that doesn't make any sense. Because this looks exactly like this, except for the constants, I have to throw in an extra t in here. 2i is a root of the characteristic equation of degree 1, and so I have to put at cosine 2t plus bt sine 2t multiplied by t to the first, because 2i and negative 2i are both roots of order 1 of the characteristic equation. Okay, so let's figure out what we have here. So that's y. I need also y prime and y double prime. Well, y prime I don't really need. What I really need is y double prime. Y double prime of t equals, okay, so second derivative of the first is 0, plus this times the second, so that's, don't have to worry about that, plus 2 times first derivative of the first, times first derivative of the second, plus the first, times the second derivative of the second is negative 4 cosine 2t. Then you do the same thing over here. Second derivative of the first is 0 times the second, so I don't have to worry about that, plus 2 times the first times the derivative of the second, plus the first times the second derivative of the second. And so that equals negative 4a sine 2t minus 4at cosine 2t plus 4b cosine 2t minus 4bt sine of 2t. Okay, so now let's try to figure out what these constants a and b are in this equation. So y double prime plus 4y equals, let me copy down y double prime plus 4b cosine 2t minus 4bt sine 2t. Then I'm going to add 4 times y, so plus 4a t cosine 2t plus 4bt sine 2t. Okay, now as expected, these cancel, and also these cancel. So that leaves me with negative 4a t, sorry, I canceled the wrong thing. This one stays, this one cancels, so this I keep. So negative 4a sine 2t plus 4b cosine 2t, and everything else cancels. That is supposed to be equal to the right-hand side, which was 3 sine 2t. So I have to match up the constituent parts. Again, matching up, clearly I get that a is going to be equal to negative 3/4 and b is equal to 0. And so that gives me a particular solution of, remember the a goes here, so negative 3/4 t cosine 2t, and then b is 0, so this term goes away, and there is my particular solution. Okay, step C is that I combine this with the homogeneous solution that I found earlier. And so my solution, the general solution of the non-homogeneous equation, is going to be cosine C1 times cosine 2t plus C2 sine 2t minus 3/4 t cosine 2t. So that is the solution of the non-homogeneous equation, except for the little detail that I still have to use the initial conditions. I want to point this out, that we only use the initial conditions after figuring out the non-homogeneous solution. So C1 and C2 I'm not going to find until I have found this general solution, including the a's and the b's. So the a and the b here I find first before attempting to find these constants that are found from the initial conditions. Okay, so now let's figure out the initial condition, figure out what C1 and C2 are. So that's y prime, if I take the derivative, I get negative 2C1 sine 2t plus 2C2 times the cosine of 2t times the derivative of that will be negative 3/4 cosine 2t plus 3/2 t times sine 2t, taking the derivative. Okay, so now let's plug in 0. Y of 0, y prime of 0. Okay, plugging in 0 into y, I get C1, and that's it. If I plug in 0 into this, I get 0. If I plug 0 into t here, I get 0. So all that's left is C1. If I plug 0 into y prime, well, that goes away. Here I get 2C2. If I plug 0 into here, I get minus 3/4. And if I plug 0 into here, I get 0 again. So that's y prime and that's y of 0 and y prime of 0. And I use my initial conditions that y of 0 is supposed to be equal to 2, y prime of 0 equals negative 1. So clearly C1 is equal to 2. And in this equation, solving for C2, I get that C2 is equal to, bring this over, I get 2C2 is equal to negative 1/4, divided by 2, I get negative 1/8. And so that finally gives me the solution of the initial value problem, that y prime is equal to 2 cosine 2t, plugging in the 2 into here. Then the negative 1/8 goes here, minus 1/8 sine 2t. Then the non-homogeneous part, or the particular solution, negative 3/4 t cosine 2t. And so that is the solution of this initial value problem. Okay, so that's that. Now, for the sake of practice and for the sake of practice only, let me do this problem again, but this time using the technique of variation of parameters to find the particular solution. Okay, so I'm going to redo part B here, where I found this particular solution using the technique of variation of parameters. Okay, so let's go back to the start. We had y double prime plus 4y equals 3 sine t. Okay, so we have our two linearly independent solutions, that y1 of t is equal to cosine 2t, and y2 of t was equal to sine of 2t. So let's figure out the Wronskian for these two things. So for the Wronskian, I put these two functions up top in the top row. And then I take the derivatives of these functions for the second row. Derivative of cosine 2t is negative 2 sine 2t. Derivative of sine 2t is 2 cosine 2t. Then I take the determinant of this matrix. Multiply this way, I get 2 cosine squared 2t. Subtract, and then I multiply this way, I get negative 2 sine squared 2t. So 2 times cosine squared 2t plus 2 sine squared 2t. So clearly the 2 factors out. Then I have cosine squared of an angle plus sine squared of an angle. no matter what the angle is, that's equal to 1. So the Wronskian is equal to 2. Okay, from this we can now figure out the things that I'm going to multiply the y's by when I find my particular solution. So u1 of t is equal to integral negative y2 of t times the right-hand side g of t divided by the Wronskian of t dt. Okay, now in my case, this is going to be equal to negative, pull out, y2 was sine of 2t. The right-hand side of the differential equation was 3 sine 2t, divided by the Wronskian of 2 dt. So I get negative 3 halves integral sine squared 2t dt. Okay, for this I'll use a u substitution. U is equal to 2t. Du is equal to 2 dt. So I'll need an extra 2 here, an extra 2 downstairs. So I get negative 3/4 integral sine squared u du. And there's a formula for that. Negative 3/4 u over 2 minus 1/4 sine of 2u plus the constant to c1. Switching back to t's, I get negative 3/4. U over 2 is t. Then sine of 4t plus c1. So negative 3/4 t plus 3/16 times the sine of 4t plus c1. So that's my first integral that I need for variation of parameters, u1 of t. The second integral that I'll need is u2 of t equals integral of y1 of t times g of t divided by the Wronskian of t dt. So y1 was cosine of t, the first solution. The right-hand side was 3 sine of 2t divided by 2 dt. Okay, for this I will use a u substitution again. So let's let u be equal to sine of 2t. Du will be equal to 2 cosine of 2t dt. So I need an extra 2 up top, which means another half on the bottom. So 3 and 4 here, so 3/4 comes out. Integral of sine 2t is u, and then 2 cosine 2t dt is my du. So I get 3/8 u squared plus c. And using my u substitution, that's 3/8 times sine squared 2t plus my constant to c2. Okay, so on screen now we have the two functions that I need, u1 and u2. So that means that I can set up my solution of the differential equation y of t to be equal to u1 of t times y1 of t plus u2 of t y2 of t. Okay, so u1 is barely on screen here, negative 3/4 times t plus 3/16 times sine of 4t plus c1 times y1, which was cosine of 2t. u2 was the one we just got, 3/8 sine squared 2t plus c2 times sine of 2t. Okay, from this point forward, let's just expand it, and hopefully we'll get the same thing that we got when we use the method of undetermined coefficients. Multiplying, we get, let's put the constants in front. So c1 cosine 2t plus c2 times sine of 2t. We had that as before. Then I have minus 3/4 t times cosine 2t. I also had that before. And then what I didn't have before was this other stuff, 3/16 times the sine of 4t times the cosine of 2t. Then I have 3/8 times the sine cubed 2t, multiplying sine squared 2t times sine of 2t. So this part, the first three terms I had before, but then I have these extra two things. Now, what I'm about to do now, I wouldn't necessarily expect on a test, but I just want to demonstrate that what we have on screen now is indeed the same thing as what we had before. C1 cosine 2t plus C2 times the sine of 2t minus 3/4 t cosine 2t. All right, let me factor out 3/16. Sine of 4t, I'm going to apply a double angle trigonometry to. So sine of 2 theta is equal to 2 sine theta cosine theta. Sine of 4t is equal to 2 sine of 2t times the cosine of 2t. That's sine 4t. Then I multiply it by an extra cosine 2t, so I get cosine squared. Okay, I'm factoring out 3/16, so I have a plus 2 here. Sine cubed is going to be sine of 2t times sine squared of 2t. So inside the brackets, I can factor out 2 sine 2t out of both terms. So C1 cosine 2t plus C2 sine 2t minus 3/4 t times the cosine of 2t. All right, I'm going to pull out the 2, that knocks out the 16, so I'm back to 3/8. I'm pulling out sine 2t. What's left is going to be cosine squared 2t plus sine squared 2t. And sine squared of an angle plus cosine squared of an angle, of course, is just equal to 1. So the thing in parentheses is just 1. So I get C1 cosine 2t plus C2 sine 2t. And here I have plus 3/8 sine 2t, the last bit. And then this third term, I'll move the last 3/4 t cosine 2t. Now I can factor out the sine 2t out of these parts, so C1 cosine 2t plus C2 plus 3/8 times sine of 2t minus 3/4 t cosine 2t. So here I have an arbitrary constant plus 3/8. An arbitrary constant plus 3/8, of course, is just an arbitrary constant. And so lo and behold, I get the same answer that I had before using the method of undetermined coefficients. So I wouldn't necessarily expect all of this trig simplification, especially on a timed test, but I did want to demonstrate that the two different techniques indeed yield the same answer.